AI is everywhere you look these days, right? Composing music, writing poetry, and now, get this, it's even trying to revolutionize the dentist's chair.
It's true. AI is rapidly changing how we think about dentistry.
So today we are diving deep, no pun intended, into the world of AI in dentistry. Specifically, the availability of dental image datasets.
Ah, yes, these data sets.
Yeah.
Essentially collections of X-rays and scans. They're the foundation for training AI to spot cavities, gum disease, and a whole lot more.
It's like teaching AI to see teeth the way a dentist does, which is a little unnerving when you think about it.
It is pretty amazing when you think about the possibilities.
Our deep dive today is based on a 2024 research report from the Journal of Dental Research. The title, get ready for it, Publicly Available Dental Image Datasets for Artificial Intelligence. Try saying that 3 times fast.
I don't even want to attempt that.
Right. But here's the catch. This report found that there are only 16 publicly available dental datasets that exist worldwide.
16.
16. That's it.
That is surprising. You'd think with all the advances in AI and the sheer volume of dental images out there, we'd have more to work with.
Right. Especially compared to other areas of healthcare where AI research is booming, 16 seems like a drop in the bucket. So
Yeah.
what's with the data drought in dentistry? What gives?
Well, it's probably a few things. Dentistry might not have had the same push for centralized data collection as some other medical fields.
Interesting.
Plus, dental imaging itself is complex. You've got your X-rays, your CBCT scans, intraoral cameras. Each one requires specialized knowledge to interpret. So putting together these data sets isn't a walk in the park.
So a smaller pool of data to draw from. What does that actually mean for developing new AI tools for dentistry? Is it like, I don't know, trying to bake a cake with only a handful of ingredients?
It's a pretty good analogy.
Yeah.
Think of it this way. Large, diverse data sets are the ingredients for a robust AI.
Okay, I'm with you.
A limited pool of information. That can lead to, shall we say, a bland AI, or even worse, one that's not that effective.
And nobody wants bland AI. And this research found the existing data sets aren't all created equal.
That's right.
Some focus on really specific things, like tooth segmentation. What in the world is tooth segmentation?
Well, imagine an AI that could outline each individual tooth in an X-ray.
Okay.
That's tooth segmentation. You're teaching the AI to see the boundaries of each tooth. It's actually really important for diagnosis, treatment planning, even for those digital models some dentists are using now.
So it's like training the AI to see the teeth like a dentist would.
Precisely.
It's amazing how specialized these data sets are. The study also found the most common image type used was a panoramic radiograph. You know, those x-rays where the machine does a full lap around your
It's
head.
a panoramic X-ray, a classic.
Why do you think those are the go-to for training AI?
Panoramic X-rays are a great place to start for AI training. They're pretty common, generally cheaper than other imaging techniques, and they give you a good overall view of what's going on in a patient's mouth.
So it's about striking that balance between getting a comprehensive image, but also one that's relatively easy to obtain.
Exactly. Efficiency is key.
Makes sense.
Hmm.
Now, the study did mention other types of imaging, things like CBCT scans, even those tiny x-rays they take inside your mouth. Is the goal to eventually have an AI that can interpret all these different types of images?
Absolutely. Think about it. A human dentist has to be skilled at reading all sorts of dental images.
It's true.
And so should AI. Ideally, we'd have AI models trained on a wide array of images that would allow them to diagnose a wider range of dental issues and hopefully with much greater accuracy.
So variety is the spice of life and the key to a well-rounded AI dentist.
You could say that.
Speaking of variety, one data set mentioned in this research that really caught my eye was Dentex. Apparently, this data set contains something like 23,999 annotated teeth.
That's a lot of teeth.
It really is. Can you explain what makes these annotations so important? What does that massive number tell us about the work involved in building these data sets?
Sure. Think of annotations like labels that provide context for the AI. They tell the AI, hey, this is a molar, or this is a filling, or even this is a really stubborn piece of popcorn stuck between teeth. The more detailed and accurate these annotations are, the better the AI can learn to recognize different dental structures and conditions.
Okay, that makes sense.
And that huge number of annotated teeth you mentioned, that just goes to show the incredible effort that goes into building these data sets. It's a massive undertaking, and we need more large-scale projects like this if we want to see AI truly shine in dentistry.
So it's not just about having tons of images. It's about having tons of images that have been meticulously labeled and categorized.
Precisely. It's a huge task, but critical for success.
Absolutely. The report also looked at where these data sets are coming from globally. Interestingly, China is leading the way in terms of sheer image count, but there are some glaring gaps.
Like what?
For example, there are no data sets from Oceania and only one from the entire continent Africa. That seems like a problem, doesn't it?
It's definitely a concern. This lack of representation from certain parts of the world raises some red flags about potential bias in AI.
How so?
Well, AI models are only as good as the data they're trained on. If our datasets mainly reflect the dental characteristics of one specific population, the AI we develop might not be as effective or accurate when used on other populations with different dental structures or who face different kinds of dental problems.
It's like trying to understand the nuances of a language having only ever been exposed to one dialect.
You got it.
Right.
We need to make sure AI in dentistry is trained on data that represents the beautiful diversity of the global population. That means including people of different ethnicities, geographic locations, and dental health backgrounds.
So, just like in so many other fields, representation and inclusivity are crucial for developing AI that works for everyone. Now, we've talked about data quantity and diversity, but something else in this research really stood out to me. The inconsistency in reporting on ethical approvals for these data sets. It turns out only about a third of them mentioned obtaining ethical approval, which seems like a major oversight.
It is a bit concerning. Transparency and ethical considerations are paramount when you're dealing with medical data, especially when it's being used to train AI. Clearly, documenting ethical approvals is essential. It gives us confidence that patient privacy was protected when the data was collected, that informed consent was given, and that the data has been handled responsibly every step of the way.
It's about building trust, right?
Yeah.
Trust in the data itself and in the AI applications that are developed from it.
Absolutely. Transparency about ethical considerations builds trust, both within the scientific community and with the public. And that trust is essential if we want AI to be widely accepted and used in healthcare.
It makes you wonder about the data sets that didn't mention ethical approval. What's going on there?
I know. It's definitely something to keep in mind. Now, on a slightly different note, this research also mentioned the FAIR principles. Have you heard of those?
They ring a bell.
They're basically guidelines for responsible data sharing, especially in the context of research and AI development.
Refresh my memory. What does FAIR stand for again?
It stands for findability, accessibility, interoperability, and reusability.
Catchy. What do those principles look like in practice?
Imagine a scenario where a researcher has developed this incredible AI algorithm that can predict cavities years in advance.
Okay, that would be incredible.
Right. But there's a catch. The data set they use to train their AI is locked away on their personal computer. No one else can access it. No one can understand how it was compiled. It's basically useless to the wider research community.
That's incredibly frustrating. So the FAIR principles are about making sure that doesn't happen, right?
Exactly. The FAIR principles push for data that is easy to find, access, interoperable with different systems, and reusable by others. This fosters collaboration, speeds up the research process, and ultimately leads to more reliable and robust AI tools.
So it's about creating a sort of common language for data, making sure everyone's on the same page.
Exactly. We need to break down those data silos and encourage sharing and collaboration.
I like it. Now, you mentioned that one of the FAIR principles is findability. I found it interesting that intraoral radiographs, those little x-rays they take inside your mouth, seem to be the easiest to find. Any idea why that might be?
That's a great observation. It's probably because intraoral radiographs tend to be more standardized than other types of dental imaging, both in terms of their format and how they're labeled. They're also relatively easy to interpret, even across different dental practices.
So they already speak a fairly universal language, which makes it easier for researchers to locate and work with them. Makes sense. But it seems like there's a bit of a communication breakdown happening with some of the other data sets. The research found that many of them didn't even specify a license for how the data can be used.
Ah, yes, the licensing issue. It's a crucial detail that often gets overlooked.
Why is having a clear license attached to these data sets so important?
A license acts as a set of rules. It clarifies how others can use and share the data.
Okay.
For example, a license might state whether the data can be used commercially, if others can modify or build upon it, or if it's strictly for nonprofit research purposes.
So it's about avoiding any confusion or potential legal issues further down the line.
Precisely.
It all comes back to transparency and trust, doesn't it?
It always does.
Making sure everyone understands how the data can and cannot be used is crucial for fostering ethical and productive collaborations in AI development.
I couldn't agree more.
This whole discussion has given me a lot to chew on.
Me too.
It's amazing how much complexity there is in something as seemingly straightforward as dental images. We've really only scratched the surface here.
We've only just begun.
We're back and ready to dive even deeper into the world of publicly available dental image datasets. Before we move on, though, something you mentioned earlier really piqued my curiosity. You said metadata is important. Now, I'm no data scientist, so could you break down what exactly metadata is and why it matters so much in this whole AI and dentistry thing?
Okay, so imagine you're trying to, say, teach a kid how to identify different kinds of birds. You show them a picture of a robin, and you're like, see, that's a robin. But let's say the picture, it doesn't show the robin's red breast, the most recognizable thing about it.
Yeah, the thing that makes it a robin.
Right. So the kid might start identifying a robin based on its shape or size, but then they might see a sparrow and think, oh, a robin, because they're missing that key piece of information.
It's like giving them an incomplete puzzle. They're not getting the full picture.
Exactly. And that's where metadata swoops in to save the day.
Like a superhero.
Kind of. It's basically data about the data. It provides all that extra context and detail that might not be obvious from just looking at the image itself.
Okay, so in our robin example, what would the metadata be?
Well, it could be anything from, like, this bird has a bright red breast,
Okay.
to it sings a cheerful song, or it likes to hang out in parks and gardens.
Interesting.
Its favorite food is worms. All those little details that help you create a more complete picture of what a robin is.
So it's like having a little bird guide entry to go along with your picture. It gives you that richer, deeper understanding.
Exactly. And for AI, which learns by recognizing patterns in data, metadata is essential.
Makes sense.
If the data is incomplete or missing that crucial context, you could end up with AI that's inaccurate or even biased in its decision-making.
So bringing it back to dentistry, what kind of metadata are we talking about with those dental image datasets? Give me some examples.
Let's say you've got a panoramic X-ray in front of you. The image itself shows the teeth, the jawbone, the surrounding structures, right?
Right. But what about the patient's age, their gender, their medical history? Are they diabetic? Do they smoke? How's their oral hygiene? All of these factors, they can significantly impact a person's dental health and how they might respond to different treatments.
So it's like having access to a patient's entire dental chart, not just a snapshot of their teeth.
Exactly. It paints a much more comprehensive picture of their overall oral health, and this is where AI can really shine. By looking at both the images and the metadata, AI algorithms can start to pick up on subtle patterns and connections that even a trained dentist might miss.
That's pretty impressive.
It's like having a sixth sense for spotting potential dental problems, and that could lead to earlier diagnoses, more effective prevention, and more personalized treatment plans.
So we're not just talking about fixing problems after they occur, but actually predicting and preventing them before they even arise.
Exactly. It's about moving from a reactive approach to a proactive approach, all thanks to the power of data.
Now, that's what I call a reason to smile. I know, right? And there are efforts underway to standardize how this metadata is collected and shared. You might have heard of something called data cards.
Data cards. Vaguely.
Think of them like nutrition labels, but for data sets.
Okay, I like where this is going.
So just like a nutrition label tells you everything about the ingredients in your food.
The calories, the sugar content.
Right. A data card gives you a standardized summary of a data set's key characteristics.
So what kind of information is on a data card?
You'll find things like who created the data set, what it contains, how the data was collected, were there any ethical considerations, and how the data can be used and shared.
So it's all about transparency, making those data sets easier to understand and use, which seems crucial if we want researchers to work together and speed up the development of new AI tools.
Precisely. Data cards could be game changers in helping us build a more collaborative and efficient AI-driven future for dentistry.
I'm all for that. This research also mentioned some wider initiatives aimed at making data sharing in healthcare easier and more secure, things like MEDA and the Global Initiative on AI for Health. What can you tell us about those?
Well, these initiatives, they're tackling the global data bottleneck in AI head-on, and not just in dentistry either. They're all about getting researchers from different countries, institutions, you name it, to work together, develop best practices for data sharing, and advocate for policies that encourage open access to data, all while still upholding the highest standards of patient privacy and security.
So it's like they're building the roads and bridges for a global network of knowledge sharing.
Exactly. They're laying the groundwork for a future where data is shared more freely and securely, which could lead to breakthroughs in all areas of healthcare.
That's exciting. Now, we've been talking a lot about these publicly available data sets, but what about all the data that's sort of tucked away in the databases of hospitals, universities, dental practices, all those patient records just sitting there? Is there a way to access and learn from that data without, compromising anyone's privacy?
That's the million-dollar question, isn't it? And it's where things get really interesting. One promising avenue is something called federated learning.
Federated learning, right. That rings a bell. Remind me how that works again.
Okay, so instead of gathering all the data in one central location, which can raise all sorts of privacy concerns, with federated learning, we basically send out little AI ambassadors to all those different institutions where the data lives.
Okay.
And these AI envoys, they can learn from the local data without actually ever seeing or transmitting the raw data itself.
So it's like the AI is going to school on all these different data sets, taking notes, but never actually bringing the textbook home with them.
That's a great way to put it. The AI models, they get trained on that valuable, sensitive data, but only the insights, the knowledge gleaned from that training is then shared and combined to create a much more powerful and accurate overall AI.
That's brilliant. So it's a win-win for everyone. Researchers get access to a much wider pool of data to train their AI, and patients can rest assured knowing that their privacy is protected.
Exactly. It's a really elegant solution to a complex problem.
It sounds almost too good to be true. Are there any downsides or challenges to this whole federated learning thing?
Well, it's still a relatively new technology,
Right.
and it requires a ton of coordination and cooperation between all those different institutions that are contributing data, plus ensuring privacy throughout the entire process. That's absolutely paramount.
Of course.
But the potential benefits, especially in a field like healthcare where data is so sensitive, they're just enormous.
I can definitely see that. It sounds like we're on the cusp of something really groundbreaking. Federated learning. It sounds like it could really shake things up, especially in healthcare, where, let's face it, data privacy is a huge deal. It really feels like we're on the brink of some major breakthroughs in AI and dentistry. But for now, let's get back to that research paper we've been discussing. The authors wrapped up by saying, we need something called cross-annotation with clinical and other types of data to really unlock AI's full potential. So cross-annotation, what's that all about?
Well, we've talked about annotations, right? Labeling those x-rays so the AI knows what it's looking at.
Right, like this is a tooth, this is a filling, that kind of thing.
Exactly. Cross-annotation, it takes things a step further.
How so?
It's about connecting the dots between those dental images and a whole bunch of other information about the patient.
So we're not just looking at an X-ray in a vacuum anymore. We're layering in other data points, like a patient's medical history.
Exactly. We're talking about their lifestyle, their family history, even their genetic predisposition to certain dental problems. It's about painting a more complete picture of a person's oral health.
It's like giving the AI the full story, not just a single chapter.
I like that analogy. It's about helping AI see the connections between, say, a patient's diet and their risk of gum disease, or maybe their stress levels and their likelihood of grinding their teeth.
Wow, it's like having AI connect those dots that might not be obvious to a human dentist just by looking at an X-ray.
Exactly. And that could lead to much earlier interventions, could help us develop more personalized treatment plans, and maybe even prevent some of those dental problems from ever happening in the first place.
So we're moving beyond just fixing problems
Yeah.
to actually predicting and preventing them.
That's the dream. Of course, there are still challenges.
Yeah.
We need to develop much more sophisticated AI algorithms that can handle this level of complexity.
Right.
And of course, we need to make absolutely sure that patient privacy is protected every step of the way.
Of course, always. But if we can overcome those hurdles, the possibilities are incredible.
They really are. We could be looking at a future where oral health is proactive, personalized, and maybe even a little less reliant on drills and fillings.
Now that's a future I can definitely get behind. And on that note, we've reached the end of our deep dive into the world of publicly available dental image data sets. We've covered a lot of ground, folks. We talked about the need for more data, more diverse data, and more transparency around how that data is collected and shared. We also explored the crucial role of metadata in painting a complete picture of a patient's oral health, as well as exciting new developments like federated learning and the potential of cross-annotation. As always, we want to hear from you. What surprised you most about today's discussion? What questions does this raise for you about the future of AI and dentistry? Head over to our website or find us on social media and share your thoughts. Until next time, keep those pearly whites shining.